Have you ever looked up at the night sky and felt small? Like the universe is too vast, too strange, too full of mysteries we'll never truly understand? Now imagine this. What if, across the entire cosmos, every electron, every single one, was actually the same electron? Not just alike, but literally the same tiny particle, weaving through time and space over and over again. The one in your body, the one powering your screen, the one born in a star billions of years ago. What if they were all the same thing? Not science fiction, a real hypothesis, proposed by one of the greatest physicists who ever lived. This isn't just physics. It's a story about identity, about time, about the strange, beautiful fabric of reality. And today, we're diving straight into it. Welcome to the weirdest idea you've never heard of. The One-Electron Universe. Is every electron the same electron? Our story begins with a physicist named John Archibald Wheeler, one of the most creative minds in 20th century physics. In 1940, Wheeler had a conversation with his student, a young, brilliant man named Richard Feynman. Wheeler asked Feynman a strange question. Why are all electrons identical? Same mass, same charge, same spin, no matter where or when you find them. Then Wheeler proposed a radical idea. What if they're not identical copies? What if they're literally the same electron, just appearing in different places and times? Here's how the one-electron universe works. Imagine one electron traveling forward through time. At some point, it reverses direction, starts moving backward through time. According to quantum electrodynamics, an electron moving backward in time behaves like a positron, its antimatter twin. The path continues, looping endlessly through time. Every time that electron's path crosses the present moment, we see it as a new, distinct electron, or positron. In this view, there aren't billions or trillions of electrons. There's only one. Zigzagging through time, it creates the illusion of many. Now let's ground this idea in actual physics. Feynman took Wheeler's idea seriously. He went on to develop a new way to visualize particle interactions, called Feynman diagrams. In these diagrams, electrons are shown as lines moving forward in time. Positrons are represented as those same lines, just moving backward in time. When particles interact, these diagrams show the paths they might take, including time-reversed ones. This time-symmetric view of particle physics fits neatly with the Dirac equation, which predicted the existence of antimatter in the first place. So, even if the one-electron idea wasn't meant to be literal, it reflected the strange mirror symmetry between matter and antimatter. But not everyone was convinced. Even Feynman himself later abandoned the literal interpretation. Here's why. If there were truly only one electron, there should be equal numbers of electrons and positrons. But the observable universe is filled with electrons and very few positrons. The hypothesis doesn't explain how that one electron chooses which path to take. It's impossible to test or falsify. So it's more of a philosophical thought experiment than a predictive scientific model. In other words, it's fun to think about, but it doesn't match reality as we observe it. Despite its flaws, the one-electron universe idea inspired groundbreaking work. Feynman's interpretation of antimatter as time-reversed matter led to real tools physicists still use today. It helped launch quantum electrodynamics, QED, into its modern form, one of the most accurate theories in physics. In fact, QED has been confirmed to over 13 decimal places in experiments. The one-electron idea also echoes in more modern theories like the block universe, where past, present, and future all exist, and loop quantum gravity. Beyond the physics, the one-electron universe makes us ask deeper questions. Is identity just an illusion in quantum mechanics? If time is just another dimension, could a single entity really populate the universe across all of it? What is individuality if particles are indistinguishable? This is where physics becomes philosophy. And sometimes, the greatest value of a theory isn't whether it's true, but how it makes us think. So, is every electron in the universe the same electron? Probably not. But as an idea, it's a beautiful reminder of how strange and interconnected our universe might be. In the quantum world, even time itself might not behave the way we think it does. And maybe, just maybe, we're all part of the same cosmic dance, seen from 1,000 angles. If this video stretched your brain just a little, go ahead and hit that like button. Subscribe for more deep dives into the mysteries of the universe, from quantum strangeness to cosmic expansion. And comment below, do you think the one-electron universe could be real? Until next time, stay curious.